Welcome to video lecture on Analog and Digital Electronics Laboratory. In this session, we'll see how to simulate JK flip-flop VHDL code using ModelSim. First, let us see what is JK flip-flop. The JK flip-flop is a sequential device with three input J, K and clock and two output Q and Q bar. J and K are control inputs. These control inputs are named J and K in honor of their inventor Jack Kilby. JK flip-flop is called as a universal flip-flop or programmable flip-flop because using its JK input, the other flip-flops can be implemented. There are two very important additional input in the JK flip-flop. They are preset and clear. Preset input is used to directly put 1 in the Q output on the JK flip-flop and clear input is used to directly put 0 in the Q output on the JK flip-flop. The preset and clear inputs of the JK flip-flops are asynchronous, which means that they will have an immediate effect on Q and Q bar outputs regardless of the state of the clock and J or K inputs. In the logic diagram of JK flip-flop, it is shown that J and K are the input and clock is the input, and here the clock is positively edge triggered and preset and clear are the additional inputs along with the outputs Q and Q bar. Now let us see the truth table for JK flip-flop for the given logic diagram. So if preset and clear are set to 0, then irrespective of clock, J and K input, output states are invalid. If preset is 0 and clear is 1, then we are going to preset the flip-flop, and when preset is 1 and clear is 0, we are going to clear the flip-flop by setting n plus 1 value equal to 0 and Qn plus 1 complement value equal to 1. In order for the JK input and the clock to be functional, the clear and preset input must be at high logic level. If inputs are J equal to 0 and K equal to 0, then there is a memory retention state, that is, the output it had before will not be changed. That is memory no change state. If the inputs are J is 0 and K is 1, Q is set to 0 and Q complement is set to 1. If the inputs are J equal to 1 and K equal to 0, Q is set to 1 and Q complement is set to 0. If inputs are J is 1 and K is 1, then the output Q and Q complement of the flip-flop change from a logical level to the opposite state. That is, if the previous state is 0, then to 1, or if the previous state is 1, the changed state is 0. This condition is called toggle condition. And all the above four cases will happen only when the clock is positively edge triggered. Now let us write the VHDL code for JK flip-flop and let us simulate it using ModelSim simulator. Open the ModelSim simulator and create new project. Give the project name and select default library as work. Now inside the project create a file and I have given the file name as JKFF and the file type is VHDL. Now open the file jk_ff.vhd and here we are going to write the code. Now I will copy the code for JK flip-flop. For writing the program, I am going to use a data type called standard_logic. This data type is present in the IEEE library. Hence, I am going to write this 2 lines of code, that is library IEEE colon semicolon use IEEE dot standard underscore logic underscore 1164 dot all. Then we are going to write the entity of JK flip-flop. Entity JK underscore FF is. So if I see the logic diagram of JK flip-flop, there are 5 input J, K, PR, CR and hence port J, K, CR, PR, CLK colon mode is in since they are input ports in and data type is std underscore logic semicolon. Here in the logic diagram q and q bar are the out. Hence q bar colon mode is out. So out std underscore logic is the data type. Then we have to close the entity end jk underscore ff semicolon. Now we are going to write the architecture for JK flip-flop architecture. Here I have named the architecture as behavioral since I am going to write the behavioral type of code for JK flip-flop of JK underscore FF is. Here input is the intermediate signal which I am going to use in the code. Hence I am going to declare input as a signal. So signal input colon std underscore logic underscore vector. It is very similar to array of standard logic data type and the index varies from 0 and 1, hence 1 down to 0. Now beginning of the architecture body begin. Now I will initialize the input value or I will assign the value to input. So input less than or equal to j and k. Here ampersand is the concatenation operator. Here I am going to concatenate the value of j and k and I am going to store it in the signal input. So here whenever j value changes or k value changes or PR value or CR or clock value changes, the output will change. Hence I am going to create a process with the variable clock j, k, PR and CR and the code is process clock j, k, PR, CR. Now inside this process I am going to use a temporary variable. So I am going to declare the temporary variable as variable temp colon std underscore logic colon equal to 0. Here this temp variable is initialized to 0 value. Now begin indicates the beginning of a new block. So we are going to write the if statement. In the truth table we have seen that if PR and CR is set to 1 then only the J and K flip-flop will work. So if CR equal to 1 and PR equal to 1 then and also we have seen that it is a positively edge triggered JK flip-flop. Positively edge triggered JK flip-flop means the JK flip-flop will change its states only in the positive edges of the clock or positive edge of the clock is also called raising edge of the clock. Hence I am going to write the code as if raising edge of the clock then what happens? Depending on the j and k value, we are going to set the output variable. So case input is, this is similar to switch statement in C. So case input is, that is here we are going to select one of the alternative based on the variable, based on the signal input. When the input value is 10, the output, here I am going to store it in the temporary variable temp. So temp colon equal to 1. So in the truth table we have seen that when j is 1, k is 0, the output is set to 1. Similarly, when jk value is 0, 1, then temp colon equal to 0. So this code I am going to write using the truth table. That is, see here the truth table. When preset is 1, clear is 1 and clock is positively edge triggered or raising edge, j is 0, k is 1, then output is 0 for qn plus 1. And similarly, when j is 1 and k is 0, output qn plus 1 is set to 1. Hence, I have written these two lines. When 10, that is input equal to 10, input is nothing but j and k is 10, output temp equal to 1. When input is 0, 1, temp is equal to 0. Similarly, when input is 1, 1, temp is not of temp, that is in the truth table also it is mentioned qn plus 1 is equal to previous state complement. When others, it is null, means we are going to preserve the value of the JK flip-flop, that is no change state is represented using this statement. When others, assignment operator null. End case, which indicates the end of the case statement, which is very similar to switch statement in C. Now we have to end the if statement for if raising edge of the clock. Similarly, else part for the preset and clear. What happens if preset and clear are not 1? Output is set to 0. Then end of if statement. Now we have stored the output in the temporary variable temp. Now we have to copy the output to q and q bar. Q less than or equal to temp and q bar is equal to not of temp. And then the closing of the process, that is end process, then end of the architecture using the statement end behavior. Now we have to compile the code which I have written for JK flip-flop. So go to project window. In the project window, you go to the file jk_ff.vhd, right click, select compile option, there compile selected. So in the transcript window we can see the error. So there is an error in the code. So compile of jk_ff.vhd failed with one error. Keep the cursor on 1 and click on it. So it shows the error, that is where the error is present. See error. Error is present in the line 2. So go to line number 2 of the program and correct the error. So in the line number 2 there is additional 1 written at the end of the line. So I'll delete it. Once again I'll save the program. I'll go to project window, keep the cursor on jk_ff.vhd file, right click, compile using compile selected option. In the transcript window, you can see the error again. There are errors. So go to the error option and see the error. So here in the line number 5, semicolon was missing, add the semicolon, and if any other errors are present, correct the errors by going to that particular line and checking the syntax. Now once again I will compile it. Compilation was successful. Now we have to go to the work library and we have to simulate the JK flip-flop. Go to library. In the library, click on work. Go to JK_FF file. Keep the cursor on the JK_FF and simulate. Now you can see the simulation window. See here in the wave window, we cannot see any waveform. So we have to add the waveform. Go to the simulation window, keep the cursor on JK_FF, right click, add wave. So now waves will be added. Yeah, J, K, PR, CR, clock, Q, Q bar, etc. Now we have to set the value of the waveform. If you want to move any waveform up and down, so keep the cursor on that particular waveform and move it. See here, PR, CR, initially it was CR, PR. Now we have to set the value according to the truth table. We have to set the value of CR and PR to 1. Then we have to set the clock. So keep the cursor on the clock, right click, go to clock, click OK. Now we have to set the JK value. Initially we'll set it to 1 month, 001001. So first set to 11. Now run the waveform. I'll run it twice so that I can see the toggling effect. Initially J and K are 1. Initially Q is 0. Next Q is set to 1. So we can see the toggling effect. Now I'll set JK to 00. Run the waveform. So you can see previously J is 1, Q is 0. Now Q remains in 0, hence the previous state is 0. Now we'll set K to 1, run the waveform. So when J is 0, K is 1, Q value is set to 0. Now we'll change J to 1 and K to 0. run the waveform. So when J is 1, K is 0, output Q is 1. So we have verified the truth table. Once again, we'll look into the waveform. When J is 1, K is 1, Q will toggle between 0 and 1, 0. So here you can see Q0, Q1, Q0. When J is 0, K is 0, Q will remain in the previous state. Previous state is 0, hence it will remain in the previous state. When J is 0, K is 1, Q will be 0. Similarly, when J is 1 and K is 0, Q will be set to 1. With this, we have simulated JK flip-flop by writing the VHDL code in ModelSim.